Welcome once again to my YouTube channel. So our today's topic in physics, wave motion. Now let's understand what wave is. Wave can be defined as a disturbance which travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium. Now let's take it on the board. Wave can be defined as a disturbance that travels through a medium, transferring energy from one point to another without causing any permanent displacement of the medium itself. Is a disturbance, yes. And you know what it means when someone or something is said to be a disturbance. That means it can cause a destruction, although that destruction is not permanent. It can cause the reshape. It can cause a disfigure. It can cause a damage, though not permanent. It transfers energy through a medium. Medium, it could be air. Medium could be spring. Medium could be water. Medium could be string. This medium allows wave to pass through it, though the medium is the source of generation of that very wave. Then the medium will also allow what wave to pass through it. It transfers energy, yes. That's why when you enter water, at times the water will now carry you from one point to another because there is what wave which does the work of pushing you away. That wave carries energy as it moves. Now it does not cause a permanent displacement. So the medium itself will still regain its shape after the wave must have traveled through it. Now we are going to look into two basic classifications of wave motion. Now we have two basic classifications of wave motion. One, that's the classes or classification of wave motion. One, we have mechanical wave. The mechanical wave. And the two, we have electromagnetic wave. We have electromagnetic wave. Now we are starting with this mechanical wave. Now what do I mean by mechanical wave? The mechanical wave. A wave that requires material medium for its propagation or for its spread. Such a wave is said to be mechanical wave. Hence, mechanical wave can be defined as a type of wave that requires a material medium for its propagation or for its spread or for it to be generated. Okay? So, mechanical waves depends on material medium. Without material medium, mechanical waves cannot be spread. Mechanical waves cannot be generated. Mechanical wave cannot be transferred. Now let's think about wave generated as a result of vibration of air. When air vibrates, sound is generated. Hence, we term it sound wave. When you vibrate water, wave is generated. Hence, we call it water wave. When you vibrate spring, wave, spiral spring precisely, wave is generated. We call it spring wave. When you trigger string, rope precisely, you see how it moves. So as that wave is transferring energy, it causes the what? The kind of this curvilinear motion, okay? So such a wave is generated by vibration of a string. Hence, without all these mediums such as string, such as water, such as air, such as spring, the wave cannot be generated. Such a wave is said to be mechanical wave. Then another class of wave we have is electromagnetic wave. Now, electromagnetic wave does not depend on material medium for its propagation. So, electromagnetic wave is defined as a wave which does not require material medium for its propagation. So, what it simply means is that whether there is material medium or no material medium, it will not prevent such a wave to be generated. It will not prevent such wave to be spread. It will not prevent such a wave to be propagated. Hence, we term it electromagnetic wave. Now, we have electromagnetic wave, which I can put in this very way. RMVIUXG, which I termed Armivus G, where this is radio wave, the radio wave. We have this one as microwave. Then we have this as visible, the visible spectrum or visible light. We have this as infrared, the infrared wave. We have this as ultraviolet, the ultraviolet wave. We have this as X-ray. We have this as gamma ray. Now, all these are what? Types of electromagnetic waves. Electromagnetic waves. These are what? Electromagnetic waves. So you can say the examples of electromagnetic waves. So here you have the visible light. That's the normal light. The light we use in seeing. So we term it what? Electromagnetic waves. So light will transfer energy, whether there is material medium or no material medium. The light does not require material medium. So whether material medium or no material medium, the light wave ought to be propagated. Now let's look into types. The types of wave motion. Basically, we have two types of wave motion. We have the transverse wave. We have longitudinal waves. So the two types of wave motion. We have the transverse. We have the transverse wave. We also have the longitudinal wave. Now, what do I mean by transverse wave? A transverse wave is just a wave in which the direction of vibration is the source producing the wave. So when the direction of the vibration is perpendicularly to the direction of the wave produced, such type of wave produced is said to be what? Transverse wave. I repeat, the transverse wave is a type of wave in which the direction of the wave is perpendicular to the direction of vibration of the wave. So when water, for example, is vibrated up and down, as we are heating water on its surface, you see the vibration will be going up, down, up, down, up, down. While that very wave will now sail on the surface of the water, it moves horizontally. So in that very case, we now have what? The wave generated being perpendicular to the vibration, which is the source. So in that case, the transverse wave, we have it represented in this very way. It moves up, down, up, down, up, down. So let's say that here is the horizontal, okay? Here is y-axis. Then x-axis depends on this y-axis. So now it moves up, down, up, down, up, down. So such wave will now move in this horizontal while the vibration is moving up and down. Okay. Now we are getting two terms here. We have here to be called crest, while we have here to be called trough. Now, the maximum vertical displacement of particles of the wave, that is what we termed crest. The maximum downward displacement of the particles of the wave, that is what we call trough. So, the crest and the trough, these are the two terms you can see under transverse wave. Hence, this is what? The transverse wave. Then remember, the direction of the generated wave is moving in the horizontal axis, while we have the what? The vibration moving up and down along y-axis in the vertical direction. So meaning that we have what? The perpendicular relation between the direction of the wave and the direction of the particle. So we have it in this very way. So such is said to be transverse wave. Then another case is longitudinal wave. If the vibration, I mean the direction of vibration, is parallel to the direction of the propagated wave, the generated wave. If the generated wave is in parallel to the direction of the vibration, then we say that what? Such a wave propagated or generated or spread is said to be a longitudinal wave. Okay, so when you have the longitudinal wave, let's say we have a spring. Now, at a point, here is compression, then here is rarefaction. Now, or let's say we have the finger that's holding this, while here is fixed. So as we are trying to vibrate this very spring, at a point, it will be closely packed. At a point, it will spread away. Okay? Now, in that very case, we talk about compression and the what? Rarefaction. Now, the longitudinal wave, as you are compressing the wave, look at the spring. You are compressing the spring, right? Now, that very region, on that very longitudinal wave, where the particles are closest to each other, that is where we call compression. But that region where the what? Particles are far apart from each other, that's where we call rarefaction. Okay, so in that very case, the compression and the rarefaction, these are the things or the terms we normally encounter whenever we are dealing with longitudinal wave. So longitudinal wave, the direction of the compression and the rarefaction is moving in this very way. Then the direction of the generated wave also moves in this way. So in that case, they are parallel to each other. So when the direction of propagation is the same with the what? The direction of the generated wave, we term it what? Longitudinal wave. Now let's quickly move into terms in wave. Definition of terms. So we look into terms used in describing wave. Firstly, we are going to look into cycle. The wave cycle. So what do I mean by wave cycle? Now, wave cycle is a complete oscillation. That's the complete toe and the flow motion. The complete toe and the what? Flow movement. That is what we refer to as cycle. So cycle is a complete what? Oscillation of a vibrating particles. The complete what? Oscillation of a vibrating particles. That is a cycle. So when we talk about cycle in that very case, take for example, we have a body moving from a particular point, then it returns to that very point. It has completed a cycle. Think about a body moving in a cyclic path. It starts from one point, it completes that very cycle by returning to that very position. So in this very case, when you have a particle, it moves up from this very equilibrium position, it moves downward and return to that same equilibrium position. We said that it has completed a cycle. It has completed one cycle. So here we refer it as a what? As a one cycle. So in that case, this is the wave. The what? The upward motion, the downward motion, join it together, it gives you what? A cycle. Now, we talk about amplitude. That's another term, the amplitude. So what do we mean by amplitude? The amplitude with the symbol A. Now, amplitude is the maximum displacement of a wave. I repeat, the amplitude is the maximum displacement of a particle from its mean position. Now, when you are vibrating water, then it vibrates, those particles move up, then downward. Then we have the particles moving up in all these directions, in this very direction, but the very one that is highest is this very one. So we term this what? Amplitude. So amplitude is the maximum upward what? Displacement of a particle from its equilibrium position. Okay, or you can say it is the length of the crest or the length of the trough from its center. So you can measure here from here to here. That is amplitude. You can also measure here from here to here. That is amplitude. That is what? The length of the what? Of the crest or the length of the trough, okay, from its equilibrium position. That is amplitude. Now, amplitude is measured in what? In meter. So the unit of amplitude is meter. SI unit of amplitude is what? Meter. Then another term we are to look into is wavelength. The wavelength. This is a symbol of wavelength, lambda. Now, what's this very wavelength? The wavelength can be defined as a distance covered by a wave when it completes one cycle. The distance covered by a wave when it completes what? One cycle. Now, let's understand this very wavelength. Now, for this wavelength, we are going to look into longitudinal wave and also transverse wave. Now, for transverse wave, the wavelength could be taken in this way. We have up motion, down motion, up motion, down motion. Now, here you have the crest. You have the crest. Now, the distance between the crest or distance between two successive crests, that is the wavelength. Or you can also say the distance between two successive trough, that is the wavelength. So wavelength for transverse wave is the distance between two successive crests or the distance between two successive trough. That is wavelength, measured in meter. Then for longitudinal waves, for longitudinal waves, we have the vibration in this very way is compacted here. Maybe we call here as crest. Then we have here as trough. Then again, we have, we have here as compressed region. We have here as rarefaction region. Then we have again the compression region. Then we have the rarefaction region. Now, all these region, we have the compression region, we have the rarefaction region, we have the compression region, we have the rarefaction region. Now, coming to this compression region, then the distance between two consecutive compression is also termed what? wavelength. That is for longitudinal wave. Or you can also say the distance between two successive refraction, here from here to here. The distance between two successive refraction is also a wavelength. That is for longitudinal wave. Then another term we need to understand is frequency. That's the frequency. Now, what do we mean by frequency? What do we mean by frequency? Symbol is F. Now, frequency is the number of cycle made in a second. Frequency is the number of cycle made in a second, or the number of cycle completed in 1 second. That is frequency. For example, when you have the wave moves in this way up and down, this is 1 cycle, another cycle, another cycle. Look at, from here to here is 1 cycle, then from here to here, okay, is 1 cycle, then from here to here is another cycle. So we now have what? 3 cycle. 1, we have another one, 2, we have another one, 3. Now the 3 cycle, because we see this as a cycle, right? So the 3 cycle in a second, if in a second, then the wave covers 3 cycles. We said that the frequency is what? 3. Hence, we have frequency measured in per second, or you said hertz. So the frequency is measured in hertz. So the frequency is number of cycles covered in a second. Then another term there is what? Is period. The period. Then what do we mean by period? Period is a time. Period is a time taken to complete 1 cycle. So period is a time taken to complete 1 cycle. N is a number of cycles. So if you are completing 1 cycle, the time it took in order to complete that 1 cycle is what we call period. Now, period is also measured in what? In seconds. So period is measured in seconds, meaning that period is talking about time. Now, there is a relationship between frequency and the period. Now, the period is a reciprocal of frequency, or you said the frequency is a reciprocal of period. That is a relationship between frequency and the period. The angular frequency . So what's the angular frequency? Okay. Now, angular frequency is the angular distance made in a second. Angular frequency is the angular distance made in a second. Okay. Now, that angular distance, if it is 360 degrees, that's completed what? 360 degrees. Then we have it as 360. Now, the time it took to complete such is said to be period, because period is the time taken to complete 1 cycle. Here, we consider what? Measurement in radian instead of degrees. So, angular speed, 360 degrees is equivalent to 2 pi radian. So, we have 2 pi radian then over period. So, we have this as angular speed. So, let's solve 1 or 2 exercises using these very terms here. Now, in solving this very exercise, there is one thing you should bear in mind. Out of the parameters I have given to you, out of those terms I have explained, there are 3 major terms there. We have the frequency, we have the wavelengths. Then again, there is a speed of a wave. Now, 3 of them are related together in this way. We said the speed of a wave is equal to frequency times lambda. Please get this very formula. The relationship between the what? The frequency and the wavelength. Remember, the speed is measured in meter per second. Frequency is measured in hertz. Wavelength is measured in what? In meter. Now, from this very question, we are asked to find the wavelength of the radio wave. Now, in order to solve this, we write down the parameters. Now, a radio station broadcasts at a frequency of 400 kilohertz. Hence, the frequency is what? 400 kilohertz. Now, you can convert this kilohertz to hertz. Now, the kilo means what? 1000, which means we are getting 400 kilo times what? 1000 hertz. If you multiply this, you are getting 400,000 hertz. So this is the frequency. Now, if the speed of the wave is given as 3 exponential 8, that is, the speed is 3.0 times 10 raised to power 8. Then calculate the wavelength of the radio wave. Now, what's the wavelength? Now, wavelength, you know the formula, that's the relationship between speed, the frequency, and the wavelength. So in this case, we're looking for what? Wavelength. Where you know that formula says the speed is equal to frequency times wavelength. Why we are now looking for wavelength? Make wavelength the subject of the formula by dividing both sides by f, which is the frequency. So we have the wavelength to be speed all over frequency. So at this point, we have to substitute the parameters. The speed now is what? 3.0 exponential 8 divided by the frequency. Now frequency is 400,000. Okay? So at this very point, we have to simplify this. So you can do the solving and feed me with the answer in the comment section. So do well to subscribe, share, and turn on notification if you have not done that. See you on our next class.